I have here a comparable diode that I believe will exceed the specifications of the original diode. It comes from Mike's Parts Bins collection, as I don't really stock solid state stuff, but from Mike's stuff I always seem to find something whenever I need it. Thank you, Mike. And I'm going to put this in where the old diode was. Since we know that we're talking about a problem at the rectification portion of the power supply, once this is added, we're going to be slowly ramping up voltage. We're not going to be turning it on at 120. We don't care about the rest of the function of the radio. It's no longer important. What we are going to do is hook up permanently the voltmeter at DC at the capacitor before and after the voltage dropping resistor, which is essentially connections off of the replacements of the filter caps right here. I'll just pick the one before the voltage dropping resistor. It doesn't matter to me, as that one already provides a reference value of 80 volts, which is good. And slowly ramp it up until we reach that voltage. You know, hopefully that should fix it, is my expectation. And then we'll see what we have as far as an input voltage. New diode installed. We can see a lot of blue spaghetti tube heat shrink in this area of the power supply. There'll probably be some more here before I'm finished. Let me hook up the multimeter now to this section of the power supply. I use some extensions with some alligator clips to safely bring this to the radio instead of using the probes. And what I'm going to do is slowly bring up this variac, and I don't mean to full voltage, I mean maybe to 30 volts and that's it. I've got it connected to B. B is our connection without the voltage dropping resistor, and that's why I've selected it. It's right here. That one should be 80 volts at 120. We're not going to see 80 volts. We're going to see substantially less. But let's start giving it some voltage, and we should see what I hope is a linear climb from 0. And I'm not going to be able to see the meter, so I'm just going to go by the dial here. So I'm going to start lifting it off, and we are seeing DC form. Now, mind you, I saw 2 volts at 120 volts last time, which was really bad. So we're now at 10 volts, and now I'm seeing 1.3 volts DC. That's a good sign. I'm not going to take this any higher than 30. I'm at 20 volts right now, and I'm seeing 2 volts output. Yeah, this is looking a lot better. And now just 30. There we go. So things are definitely improving now. I'm sure if I look at it on the oscilloscope as well, I'll see a much better improvement, obviously because we had no diode before. I mean, but it should be a lot better now. So this thing can produce DC now, but whatever caused this initial problem, whatever burned out this resistor and the diode is still in there. Right now, because I'm not using any real voltage, it's safe. I'm not blowing anything up. And that's why I wanted to start really low. I'm going to increase the voltage slightly, and you see there's, you know, DC, and then you're watching it drop back down. And as I increase it, see it pulls down. And then it starts to destabilize. If I increase it again, it pulls back down. Something is pulling this DC down. So there are still problems in this circuit, and you can see that as I increase the AC, and it pulls that DC down, it becomes more and more unstable. Right, the filtering only does so much. And then you start to see more and more ripple in there, as we're seeing right now. So now I'll lower it. If I just turn it up just a little, it almost looks a little like it's stable. But something else upstream is still bad. I'm gonna have to see what I could disconnect on the circuit here to find out at what point this power supply stabilizes. I mean, as it stands, we do not even have a stable power supply at this point yet. You know, could be anything. For all I know, you know, it could be any number of components that are pulling an excessive load on this circuit right here. I decided to lift one side of that 6.8. That'll clear up one of these 2 rails from the power supply and give me one section to work with. That makes the top one go away. If there's any problems, all I have to deal with the one is that bottom rail that leads out here to this portion of this coil and this capacitor over here to deal with. I lifted it safely so it'll be easy to reinstall later. Whatever it's doing only showed marginal improvement, and that marginal improvement was probably only because whatever current was being used on the second rail was alleviated, but the main problem still exists, which means that it's probably sitting on this bottom rail here, and now I'll have to further investigate, probably by trying to find a good way to detach this second rail as well. I'll have to see where a good place is, probably where it meets this coil here, if there's a good avenue to do that. It comes to the collector of this transistor here, Q4102. If that's the case, no pun intended, then this entire metal shield is the collector for Q402, and it would have to be disconnected from this, or the transistor would have to be removed to disconnect this from the rest of the circuit, assuming that there was no other shorts to ground from this case. Seems like an incredibly stupid idea to run 80 volts through this entire metal shield right here. I definitely wouldn't run them full voltage like this, but this is a good way to isolate the transistor. The collector is now floating. You would think a metal piece like this was ground, but nope. This is like 78 volts. Anyway, obvious discovery here. You know, this coil is actually acting as a choke for the filtration of this power supply as well, which also causes, you know, because of its internal resistance, a voltage drop here. So the 80 volts that comes out of here turns into 78 volts on the collector, which would be expected. I could do the math and tell you what the resistance is of the coil, but I really don't care. But it may become relevant shortly when we want to find out if this coil is operating correctly and make sure there's no shorts or whatnot going on in there. But right now, we're just checking to see if there's excessive drain caused by this transistor. A little plastic there just to be safe. Figure might as well get the oscilloscope in on the action here. There's really nothing left to impede this circuit as far as short due to bad circuitry, unless this metal plate is shorted to ground. I'm hesitant to think that that's an issue. So what I'm going to do is I'm going to start dialing this up very slowly. We'll take just a little bit of voltage here. Like I said, this is just a power supply exercise, not a radio exercise. If it's looking good, I'll switch over to the hand tech. We'll have a gander over there. See what we got. We'll try and surpass 2, which is all we could have done. And remember, this is also through the choke, so it should be cleaner, but a little lower. Let's see if we can get anything. You're definitely getting somewhere. This metal cage represents a positive voltage. Right here, this is the metal cage that, the way I have this currently set up and with the transistor removed, there should be no path to ground right now. It essentially just comes up and goes to a plug which is not plugged in. I have even disconnected that plug. And the other side of my test set is going to the chassis ground right here. So I would expect that a resistance reading would be open. Alas, it is not. I am seeing 13k ohms of resistance. And quite frankly, I have no idea why. I've looked on the bottom of the board too to see if maybe I have some sort of solder blob or something, some sort of short that's shorting this to something that is 13k ohms, and I'm just not finding it. And the only thing I could think of is one or more of these 2 capacitors right here that I installed to ground and somehow have a problem with one of them. Time to investigate. In looking at the schematic, I realized that this electrolytic capacitor here, if there was an issue, can make a path to ground directly. I've removed that capacitor for testing. In the meantime, I've replaced it with a 220/25, slightly higher capacitance of even rating, just to see. And I'm going to hook it up to the IT11, see what we got. Rated for 25 volts. We're going to go in the easiest setting, electrolytic, and start at 3. Okay, so 25, it is good. I've removed this coil from circuit for a myriad of reasons, the least of which was to test it and put it on the inductance meter here. We see it as 2.2 henries. And that tells me, most importantly, this coil is not shorted internally. not on the primary winding anyway. Secondary winding for the speaker would not affect this portion of the circuit. I will tell you, with this removed, we still have the same power supply issue. I'll be damned. There is now nothing coming off of here, and and we can't get more than 6 volts out of this thing. It's unbelievable. I ripped off every component coming off of track C. That is, the middle connection is shown here from where the old electrolytic capacitor used to be, in an attempt to find why track C and track B have that resistive value of 150K. Looking at the movie, try and establish why you think it exists. I think I may have found it. I'll give you a second. If you guessed it was because of the pencil that I used to draw the letter C between the two connections that was causing all sorts of terrible issues, come forward and claim your prize. Unbelievable. I've literally removed everything from this section in an attempt to find this. Looked at this diagram, racking my brain, staring at the letter, and still not getting it. And I just licked my finger and wiped it, and it went up, you know, like 50K, and then wiped it 5 more times. It went up to 2 megs. I'm going to clean it now with alcohol and make it go away. Currently have the variac dialed up to 60 volts as half voltage, reading directly off the rectifier, showing 40 volts, fluctuating here and there. Also see it climbing. Probably a couple of electrolytic capacitors that haven't seen voltage in a while are forming slowly. This will probably taper off. It looks like the power supply is starting to come together on this thing. I start to have my doubts, but yeah, how about that? Been sitting here for 5 minutes now at 60 volts, and I put on the laser on both sides here, and they are only reading 80 degrees each. So they are no longer cooking. That's pretty good. I think we're ready to bring it up to like 90 or 120 volts. Take a look at this. Power supply looks like it's fixed again. I have very carefully reintroduced this coil, which during the course of troubleshooting I've had the luxury of actually testing the coil itself out of circuit, so we know how many henries of inductance it has, the resistance and what have you. So that was a positive thing. Now further testing of the power supply will be done onto this metal cage. I still have not reintroduced the power transistor at this time, but that will be up and coming. The power transistor back into circuit, and I am doing just a regular test right here off of the collector. And what I'm seeing now is the 1-to-1 voltage ratio I saw before when it was unladen is now no longer seen. We're at 70 volts, seeing DC of 41, where we were seeing about 1-to-1 before. When I had it on 80, I was seeing 80 out. Right now, the meter is showing 80, and I'm now seeing 50 out. So, dramatic volt reduction, obviously very current sensitive, is what we're seeing in this circuit. I will be monitoring these resistors and see what's going on with that for a couple of minutes before I shut it down. But I'd also like to take some measurements. The back of that power transistor is a nice place to take some readings with it back in circuit. We know what this one is because we're reading it now. Adjusted for voltage, obviously, showing 50 at this time, supposed to be 78 at 120. We're seeing 50 at 80, which I guess is okay right now. I want to see what this one is going to bring. This is feeding the base on this transistor and this transistor. Make sure that's okay. I just got to say, for the purpose of this test, I have exactly 120 volts, 119 and change on the variac right now, and I am seeing 80 volts appearing on the collector, and that is absolutely perfect. That's what I want to see right there. So it's time to start moving down the line here with the power supply and see what we got going on. Start taking some measurements along the way. Seeing the same voltage along both sides of this 4.7 microfarad capacitor. It's making me wonder if there are some issues with this one as well. And that voltage is 12 volts. This is rated to 16. It's a good enough candidate for removal and inspection. I'm going to do that now. Having replaced that capacitor, I found that a significant path or leakage was alleviated in the circuit, and this was about 20 volts, and it's hard to say exactly what it was doing. Obviously, I can't exactly quantify it, but I put a much higher rated one, and it's not the rating that saved it. It was just the fact that the original capacitor was old and now it's been removed. Another note that I'd like to point out is this is extremely sensitive to really anything that doesn't align itself to the actual circuit. So just by having the thing plugged in and not having the finals impedance matched is enough to set this thing off. I've decided that for testing, I would be hooking up the speakers to balance the impedance on that side of the output transformer. Now that we have the power transistor back in play here, this large one here. And in setting things up and looking at voltages, I was also able to observe the initial performance of the radio. I'm going to pause here so I could turn all the power on so I could demonstrate that now. The speaker is sitting over here. The little capacitor appendage of the speaker is not connected. It's not relevant to this. Also, the external antenna is also not connected, and the FM antenna, which bolts onto the back, is not connected. This is the 120.
Is it a time you do something for you? Call 855-2.
The radio is currently on FM right now. I don't want to make it too loud for this video, so I'll lower it.
Join the Winter Park Chamber of Commerce for the 32nd annual Taste of Winter Park, presented by CenturyLink on Wednesday, April 19th. Indulge in culinary creations from Winter Park's top chefs, bakers,
I'll just go through right quick.
confectioners with
Ability and a feeling of luck.
So FM is working fine. There's also a middle FM setting that automatically locks onto the station. Apparently, I haven't gone through the full theory of operation, but as far as the circuitry goes, it's you go to that setting and it's not dying. But I could use an auto phase control. So that's FM, basically that's FM right there. And I'll switch to AM. And AM will come in better because AM doesn't require an external antenna. AM has this antenna in here. So AM works well in this position.
It happens after you make a few easy shots. So you feel like you have the green light to take a couple more.
Has done more to help than Walmart.
It's a lot of fun when you're in that zone.
Raise range and you're ready. Here's the 0-2 pitch. Swing and a foul on a play to the right side.
Envidia de piso. Solo piensa que nosotros lo haremos por ti.
Sofía, toma di, que esta pena comienza.
So the radio appears to operate fine. It leads me to this conundrum that normally you're faced with. If the radio were operating like this, would you open it up in the first place? Now I could still go through and do the calibration of the radio because I do have the instructions for this. And mind you that this is done with the radio back in the chassis. It's not something that needs to be done on the bench like this. And that's fine. The question is, given the condition of this phenolic material and these boards and all the stuff that I've had to lift off and transistors and what have you that I've disconnected to break open pieces of this circuit. Another thing that I've learned, that I've known, suspected, however, that, a voltmeter checking connections on these transistors isn't always very effective. You need a VTVM on here, very high impedance meter, because the meter itself will skew the results. Is how much work do you really want to do at what point to inspect every single facet of the radio before you run the risk of actually breaking the unit, becomes a conundrum. So when it works well, do you just leave it alone? And I think that's a point where we're starting to reach where it may be about time to put it back in its case. A lot of the electrolytics were replaced. The ones that are still in there don't demonstrate or appear to demonstrate any significant problem. Those could be tested in the safest possible fashion, the remaining ones, and I think that's about it. I went through the IM11 on here on some of the points that I just wanted to make sure weren't being skewed because of the Fluke 25. As it turns out, yeah, this is not vacuum tube equipment, and the Fluke was working just fine. Contentious issue that was bothering me is the fact that the readings go from positive to negative. This positive 20 right here starts reading as a negative when read on the base, for instance. I'll just use this base example here. So the 20 going to a negative 7, is dropping. 20 plus 7 is 27 volts off of 15. And that really didn't make any sense to me. But they start talking about how voltages are read with respect to ground. And still, that's an awful lot of voltage. And this is kind of crazy. And yet, it's working, so I'm not questioning it. And like I said, I really could get into the nuts and bolts of this, and I could break the radio and destroy it trying to figure out how this works. Or I could simply accept it. The voltage in is higher. The voltage out is higher by magnitude. Same thing on this transistor, but they're all higher equally, as well as some ones up top there. Leads me to believe that I'm either measuring it slightly off, or the schematic here is not correct, or it's for a different model, or slightly different model. I don't know. I'm not going to spend too much time on this. The radio appears to be operating correctly.